Alright, this lesson we're looking at fitting a least squares regression line. So when we have a scatter plot, we have our two variables here, and if we find a line, so let's say all of these are our data points, and you can see it forms a linear trend, and if we can fit a line that has the least distance possible from each of the dots. So you see these red lines, they're distance from the actual data to the line that we're fitting. We want this distance to be as little as possible, so the line that we draw fit the data the best. That's our goal when we're fitting a least squares regression line. Now, when we talk about least squares regression line, there are a few things that the name gives away, such as the squares. So where the squares name, the word squares in the name come from, is what we're doing with the line. We're actually squaring, so we're putting this distance and like putting it squared. We're squaring all this distance together to find the minimum amount possible when we're fitting the line. And all these distances that we have between the actual line and the actual data points, we call them residuals. So all of this we're going to look at in more detail in the topic later on. But for now, we're moving on. We just know at the moment we fit a line that has the least amount of distance from the data and the line. Now, when we're fitting this line, we are making some assumptions. We're making assumption that it's a linear trend. The association is linear. There's no outliers. And we're using numerical variables for both x and y. As you might remember from last year, the equation that we'll use for this line is y equals a plus bx. And we can find these values, and when I say these values, we're only looking at a and b values. When we have our equation, we'll have x and y as is, and we'll have some other numerical values for a and b. So the way we know how to find a and b is to use the cas. So for example, if we have data x and y and we're given all these values for x and y, we're putting them in this order and making sure that if you put 5 first for x, then you put the 7 that comes with the 5 on the y. And we're labeling the columns as well on the cas. And once you redo all that, and then we go menu, statistics, stat calculations, and linear regression a plus bx, then it gives you all of these values that we need to do so to find the equation of the line. And the things we're looking at the moment is a and b. So, and simply these are just numerical values that were given, and we put them into the equation where we see a and b. And that gives us the equation that we're looking for, which is a fairly simple process. We just use the cas, put those in. So for example, if we use this example, so it's a plus bx. So here we're given a as 1.5. Let's just use 2 decimal places, so 1.54. So you just write y equals, and wherever you see a, you put 1.54 plus, and wherever you see b, we do 1.34, and then you write x. And this is our equation that we're looking for. Now, we can also find this equation, and this is new for this year, when we know different stats for our data. So using other statistics, we can find the equation of the line as well. And what we need are the mean. So mean for x and y. So we have 2 variables. And then if we also know the standard deviation for x and y, and if we know the correlation coefficient, the R value between X and Y, as long as we know those 5 values, we can also find the equation of the least squares regression line. And the way we do it, to find A, we take the mean of Y and minus B. So B is the value, like same value as this B here, and also this B here, and times with the mean of X. And to find B, all we need to do is take the R value, times it with the standard deviation of Y, divided by the standard deviation of X. So in reality, we'll do this first and we'll do this second, because to do A, you need the value of B. And to find the value of B, you can do it this way. So putting this into practice, so this has a lot of context. So what I like to do is to write all these symbols, notations next to the context where I see that value, just to keep track of everything. So here we're dealing with like weight and height, and we're given the mean of the weight. So average is the mean. So you can write the notation. Now you need to decide whether between weight and height, what's going to be your X and Y. Remember, on the graph where you see X and Y, you also need to make sure that your EV goes here and RV goes here. So you need to decide between weight and height, which one's X and which one's Y. And hopefully you know that the height is going to explain the weight. So height is the EV, so height is X, and weight is Y. Therefore, the average weight, the mean weight will be mean of Y, and standard deviation of weight is also standard deviation of Y. And for the height, the mean is this, so I'll just write it here, and the standard deviation is that. And we're finally given the R value as well, which is just here. So that's our R. Now, once we have all these 5 things, it's as simple as putting it into these formulas here. So I've already done it here. So wherever you see like the mean of Y, which is here, put it into there, so on and so on and so on. I don't think I need to go through that. If that's confusing to you still, please do see me in class and I'll go over it with you. And have a go at this example, very similar to this one here. You should be able to do it without much issues. So pause the video now and have a go, come back to the video for the answer. Alright, so hopefully this is what you've done. You find B first, and you do that by simply just timesing your R value and your standard deviation of Y together, so like this, and divided by the standard deviation of X. And then you can just put this into your CAS and get the value. So it should be negative 0.67. So once you have your B value, use it to find the A value. So A value is the mean of Y, so 5.6. Take away B, so 0.67, times the mean of X, so 5.3. And obviously if you put this in the calculator, it'll give you the value that you're looking for. And this is hopefully what you've got. And once you have your A and your B value, you can put it into the equation. Equation obviously takes the form of Y equals A plus BX. So now wherever you see A, you want to write 2.049. And wherever you see B, you want to write, now in this case, because B is negative, instead of writing it like this, you should realize that when we have a negative and a positive next to each other, it does become a negative. If they were both negative, it will become a positive. So in this case, it's going to be negative 0.67x. And hopefully that's one of the answers here. Now, even though the actual equation, actual data that's given to us has many decimal places, like this one has 3 decimal places. Therefore, in our answers, we'll have many decimal places. But the question actually just asks you, what is it closest to? And it only uses 1 decimal place. So it's testing your rounding skills as well. And this could obviously happen in your actual exam. This was taken from the actual exam. So then you round everything to 1 decimal place, because that's what the answers are given in. So this will be 2.0. This will be 0.7. So then you look for those. So, and then now they've made it, here we go, 2.0, 0.7. There's a negative in between. That's what we have. So the answer should be this one.